The Move, Look, and Listen podcast with Dr. Doug Stephey is brought to you by Audible. Get a free audiobook download by visiting audibletrial.com/inbound. We'll have a link in the episode notes for your convenience. Many of the books mentioned here in the podcast are available in Audible. Sign up for a free 30-day membership trial, and you can download any book you like. Support the Move, Look, and Listen podcast with Dr. Doug Stephey by visiting audibletrial.com/inbound.
If our two eyes are not working together well as a fast, synchronized team, our internal map quest continues to be off. It's consistently inconsistent with our ability to judge time and space. Those that don't feel well grounded, those that have some measure of anxiety, oftentimes it starts in the visual system. If you can't move, look, and listen in a fast, accurate, effortless, sustainable, age-appropriate, meaningful way, you're in a world of hurt. There's a whole world in vision and how it affects brain function that no one's ever shared with you. 2020 is perceived as the holy grail of going to the eye doctor. Well, I'm here to change that paradigm. Welcome back to the Move, Look, and Listen podcast. I am your host, Doug Stephey, and I want to welcome yet once again Dr. John Stein, Professor Emeritus from Oxford University. He is our longest running guest to date, and I have to tell you this, that when we were finishing the last episode, and I don't remember if this got recorded or didn't get recorded as part of the show, but we got to the end of it, and Dr. Stein graciously said, we haven't even talked about the genetics of dyslexia yet. I've got more to say. And so he's back today. And because the way we finished that show, here's how it normally goes. I normally think hard about the show we're going to do. I make notes in preparation for the episode. I try to keep the show moving in some sort of a coherent sequence, and I'm ready for it for the most part. Today, it's way different than that. So this is really going to turn somewhat into Dr. Stein's show today, and I'm going to be the guest because I don't really know what he's going to tell us.
You may not want to hear it.
Well, I think we all need to hear it, even if we don't want to. How about that?
Okay.
So, Dr. Stein, welcome back. And I'm really anxious for this show to get started because I am really interested in what you're going to share with us today.
Well, there were two things that I felt we still hadn't really covered. One is the genetics of dyslexia, and another is the talents that many dyslexics have. And those two are not unrelated.
I think that is fantastic. And it's a wonderful point to make because if you end up on the dyslexic side of things and don't appreciate the gifts that it really brings to you, it can really bruise your sense of ego and who you are.
It's very important that people should realize it's not a disaster. In fact, it might be completely the opposite. Look at all the highly successful dyslexics. I always say that if they can get through their schooling, they can often be world-class performers in whatever they want to do.
I would agree. And I think there's some famous, really successful dyslexics who kind of get hidden in the shadows and it doesn't get talked about enough.
Well, let's first of all talk about the genetics a bit. I'm not a geneticist, but I have been involved in one of the biggest genetic studies because the clinics that I run collected a whole lot of not just single dyslexics, but dyslexic families. So we started off with a study here in Oxford and the surrounding counties looking at families of dyslexics. So what we did was we persuaded families which at least one child was dyslexic and one child was not dyslexic. And we took the DNA of the dyslexic child and the non-dyslexic sib, and also of the father and mother. And sometimes we got two dyslexic kids and two non-dyslexic sibs, and the father and mother. So in the end, we had something like 900 pairs, what we call sib pairs. And the idea was to look for dyslexia as a quantitative trait. I mean, I'm sure you realize that dyslexia isn't all or not. You've got various grades of dyslexia, and it's a quantitative kind of distinction. So what we did was we looked for what is a quantitative trait linkage. So you don't define somebody as dyslexic. You say, how much dyslexia have they got? And you define a way of doing it, which we did by the difference between their literacy, that is their reading and spelling, and their non-reading ability, intelligence. So it was their reading and spelling versus their matrices, which is a test of oral language, and matrices, which is a test of their visuospatial abilities, their visuospatial intelligence, you might say, non-verbal intelligence, therefore. And as I say, we treated that as the thing we were looking for to associate with various genes. This started off in about 2000, so it was before the very large genome studies could be done, because there just wasn't the technology. Now, what we're looking for is association of this dyslexia trait with various what are called SNPs, that is single nucleotide polymorphisms. That is, we all have, as you know, 26 chromosomes, but all of us have individual variation in what's actually on those chromosomes. And they're defined by these SNPs, SNPs, or single nucleotide polymorphisms. And what we were looking for is single nucleotide polymorphisms, which are associated with dyslexia, this dyslexia trait. And we found a number of them which were statistically significant. The statistics is extremely complex because you're actually looking among something like 2 billion SNPs, and you're going to find a lot just by chance. But we found ones that exceeded the threshold of chance, which is something like you've got to have a chance of better than 1 in a million to actually presume anything about this. And we found a number of SNPs, but in particular, we found 2 genes that we were the first to find. One was called KIA0319, which doesn't tell you anything about what the gene did. And at that time, we didn't know anything about what the gene did. But we subsequently discovered that gene was concerned with the migration of nerve cells during development. Now, I have to go back a bit and explain that when the brain is developing in about the 3rd trimester, the last 3 months of pregnancy, when the brain is developing, the nerve cells in the cerebral cortex migrate from where they're born, which is around the ventricles. They migrate to form the 6 layers of the adult cerebral cortex. And what we discovered was what this gene, KIA0319, played a role in controlling that migration. And this was really exciting because we'd known from the pathology of brains that have been donated by dyslexics to Samuel Orton way back in the 30s, had ended up in what's called the Harvard Brain Bank. Studies of dyslexics in that Harvard Orton Brain Bank and showed that there were abnormalities, the migration of neurons. So this was a really interesting discovery. And a number of other genes that have subsequently been related to dyslexia have been shown to be concerned with migration. It's not a simple story, but I'll tell a simple story. And that is that KIA0319, if you block it completely in animals, in particular in rats, it will stop the migration of neurons completely. Now, nobody says that it's that bad, as it were, in dyslexics, but it certainly indicates that some degree of mismigration is one of the things that is genetically handed down and may cause dyslexia. That's a long description, but that's why we were very excited.
So if I understand things correctly, this gene is one of the SNPs that you found.
Well, it's not the SNP just points you to the gene, but this particular gene, the SNP, was in this gene that I was talking about, KIAA0319.
Okay, and this gene was found in the dyslexics, but not in the non-dyslexic siblings?
It's actually not that the gene is missing in dyslexics. It's that the gene has a particular mutation in it, which will make it behave differently in dyslexics than in other people. We all have different versions of genes, and this allele is common in dyslexics.
So this allele will be found in the dyslexic sibling, but not in the non-dyslexic sibling?
Not as simple as that, but you'll find it more often in dyslexics than in the non-dyslexic siblings.
Okay. And I suppose one of the questions that comes to my mind, and I believe that our listeners would want to know as well, is if there's a strong genetic family history of dyslexia, are there any things that could be done from at least a nutritional standpoint to try to not have that allele manifest the same outcomes in the dyslexic kid?
Well, I can't say this has been proven, but there's 2 steps towards answering that question slightly, as it were, to do with omega-3s, of course. That's why I got interested in omega-3s. The first is that we started this with a different hypothesis. We'd shown that if you give omega-3s to dyslexics, you can often improve their reading. And we'd shown that you can actually improve their magnocellular function. Now, that was followed up, as it were, by other studies that showed that if the mums of children who were dyslexic had not eaten enough fish or taken enough omega-3s, they were slightly, not hugely, more likely to have a dyslexic child. So you can see that's the way the evidence is pointing, but it's by no means proven. I must say it's still circumstantial. But you can't do the ideal experiment. You can't bring up children with and without omega-3s and see what the difference is, because that would be totally unethical. But by chance, that used to be the case, because if you didn't breastfeed your child and people didn't realize the importance of omega-3s, you found that the children who were breastfed were much better readers than the children who had been bottle fed without any omega-3 in the formula.
Right. And so the question that I was feebly attempting to ask earlier, and I think we've sort of answered it because we don't definitively know, because you can't do this kind of research. But the point that I was attempting to make was we all should be taking omega-3 supplements unless you're eating a traditional Japanese, Asian diet that has loads of seafood. Everybody else isn't getting an adequate amount.
I absolutely agree with you. That is the case. Just as a little aside, just to get people really angry, it is recently become clear that vegetarians, at the moment, that we can't say their children are more likely to be dyslexic, but what we can say is they're more likely, slightly more likely, to have mental disorders, right, because they lack the long chain omega-3s that you get from fish.
So do you think, at least from your knowledge base and all that you know, would it be a reasonable statement that at least a few months before considering becoming pregnant and throughout pregnancy and throughout breastfeeding, a mom should be taking omega-3 fatty acids in a reasonable dosage?
Oh, absolutely. Best of all as fish, as oily fish. But if they don't like oily fish, and quite a lot of people don't, then take supplements.
And then one of the questions going to become, well, can I get enough omega-3 fatty acids from krill or algae?
You can. The oily fish get their omega-3 from algae. So we can cut out the oily fish if you want and get it straight from algae. But the point about the oily fish is they concentrate the omega-3. And if you've got to do it industrially, as it were, it's a very expensive process. And that's why algal-based omega-3s is very expensive.
And you have to get an adequate amount of the components of the omega-3s, DHA and EPA, as it were, in a therapeutic dosage.
Yeah, you need at least 500 milligrams of EPA and DHA.
At least.
Per day.
Right.
Half a gram.
And on a related note, can people get enough omega-3 fatty acids from flax or flaxseed?
No, not the usual person, because flaxseed only has the short chain omega-3s, and the longer chain ones have to be made by the body, And in particular, DHA, we make very little of it from the shorter chain fatty acids, only about 1% of a dose of flax oil that you get, or rather the omega-3s in flax oil, get converted into DHA. And that just isn't enough. I mean, I personally think if vegetarians are putting themselves at risk.
Again, the point that I want to at least discuss a tiny bit further is if you've got a strong family history of dyslexia, you jolly well should be supporting yourself with omega-3s prior to pregnancy, through breastfeeding, and you need to make sure that your child continues to get an adequate amount of omega-3s to up their chances of not having dyslexia cause the potential train wreck with reading that it could otherwise cause.
Absolutely. Now, the next question I think you're going to ask me is, does that cure the dyslexia? The answer is no, and you wouldn't want it cured.
Right, which ultimately is still going to be part of our discussion today.
Right.
All right, well, let's move on to the next gene that you were going to talk about.
Well, that brings me on to omega-3 more particularly, because the other new gene that we discovered is on chromosome 18. The first one, by the way, another interesting point about KIAA0319 is that it is on the short arm of chromosome 6. And the short arm of chromosome 6 is where all your immune control genes are situated. And so there's a tie-up between dyslexia and various immune problems, autoimmune problems such as eczema, asthma, hay fever, and more serious ones like lupus. So the families of dyslexics have all those autoimmune problems. So it wasn't at all surprising to me to find that this gene is on the short arm of chromosome 6, and it's in amongst all the genes that are controlling your immune system. And so if I were an immunologist, I would call it part of the immune control system. Genes are very fascinating. I mean, if I was starting now, I'd definitely be more of a geneticist.
So let's go on to chromosome 18.
Yeah, well, chromosome 18, our gene has not been named yet, and it isn't certain which one it is, but the SNP was found close to a gene called melanocortin receptor 5. Now, that doesn't prove that it's anything to do with MCR5, but it is highly suggestive. And it's a very strong SNP. Statistically, it was well above the threshold for significance. Now, the reason I was really interested in this is that MCR, the melanocortin receptor, is really important for the control of, guess what, fatty acid metabolism. So it's still speculative. There's even less evidence about what I'm just about to say than there was about the KIAA0319, but I still think it's really interesting. The point is that this MCR5 is concerned with the way in which fatty acids are metabolized by the body. One thing that we haven't talked about at all is that fatty acids' main job are to provide energy. Fats provide twice the energy of carbohydrates. And so anything that alters the handling, as it were, of fatty acids will be really important in controlling the amount of omega-3s, if, for instance, that are available for other purposes. And again, we haven't talked about this, but the omega-3s DHA is really important for the structure of the membranes. It provides the perfect electrochemical properties for nerve membranes in particular to work properly. If it's not there, they don't work fast enough, and that's why magnocells are so sensitive to lack of them. But the point is that MCR5, or the melanocortin receptors, are very important for, as it were, controlling the amount of fatty acids that are used to provide energy and the amount that are left over to go into your membranes. And the other thing is EPA, the other very important omega-3 fatty acids, is important for controlling inflammation. And if MCR5 5 is not working properly, as it were, or working differently, it will allow less of the omega-3s to be used for the signaling and structural purposes and more of it to go into providing energy. So it's helping to control the balance of the way these long-chain fatty acids are used.
And DHA has a pretty significant role, if I remember, in the retina.
Oh, absolutely. That's the highest concentration of DHA anywhere in the body. The receptors that are converting light into electrical activity are stuffed with DHA. And if you don't have enough, essentially you go blind. One of my friends has autoimmune retinitis, which is gradually making her go blind. But I persuaded her to go on to high doses of DHA, and it was reckoned by her eye hospital experts that she was going to go blind in 3 years. She's still not blind 30 years later.
Oh, that's pretty significant.
Well, one swallow doesn't make a summer, but I think it's significant.
Yeah. Well, and it's important to her.
Yeah. Oh, absolutely.
Yeah.
She says I saved her life. So,
it's one of those examples where there's no proof this works. She's a subject of one, and it worked for her, seemingly.
No, well, she believes it.
Yep.
And so do I.
Yeah, that's hugely significant, which again speaks to why I've been beating this drum about omega-3 fatty acids for probably the last 20 years. And certainly Tim, a podcaster producer, could attest to that I've been talking about omega-3s forever.
Dr. Stephey, since you told me that probably a year and a half ago, since then, I've got this green bottle of fish oil that I replace probably every 6 to 8 weeks in my refrigerator. Now, if I can only get my family to take the fish oil, that would be great. But I have been diligent since you told me.
Well, maybe what you have to do is get them to listen to the series of Dr. Stein shows, and they will win themselves over. It won't be you tell them anymore.
I know, because they're not going to listen to their dad, right? They need to listen to a real expert when it comes to this.
Yes.
But the thing is, the important thing is the proof of the pudding is whether you think it's had any effect on you.
Well, to answer that is I really need to take another inflammation test, because that is the reason why I started on it in the first place. Remember, Dr. Stephey, when we did that? So I probably need to take another one of those tests to have some biomarkers to compare.
Well, I mean, there's a lot of evidence that EPA in particular will cut down your CPR. You know what CPR is?
C-reactive protein.
Inflammation biomarker. And regular EPA cuts it down because it helps to control inflammation. It's important to say it doesn't just inhibit inflammation, because you need inflammation for various things. I mean, if you get an infection, you need inflammation to cure it. So it's important that it controls it, doesn't simply inhibit it.
Well, mine was off the charts. So it could use some declining for sure. And there's more to decline that number than just by taking the appropriate fish oil and the appropriate amount of fish oil. There are other factors that I've incorporated into my lifestyle as well. So we need to do another one of those tests, Dr. Stephey, so we can see how well it's worked.
So, Dr. Stein, are there other genes too, or are those two really the big hitters?
Oh, no, the last count, there were 9 genes that have actually been discovered, 2 of them by us, so I'm rather proud of that. But another one that was discovered on chromosome 6, actually, called DCDC2, and that's interesting because it's been shown by an Italian group that particular gene is associated with specifically in reduction in the motion sensitivity of dyslexics.
Oh, my. I got to go read about these.
There are others. I can't recall them all at the moment, but as I say, there are 9. And I should emphasize that these alleles, actually each of them has tiny effects. It's not as if you've got one of them, you will definitely have dyslexia. They contribute, and there are probably many others that have even smaller effects. They contribute to the overall package of dyslexia. And it also explains why every dyslexic is different, because It's not just, as it were, the one gene that I talked about, KIO31, affecting neuronal migration, or just the one that I've talked about that is controlling fatty acid balance, but it's a whole slew of genes, all of which have to interact in rather complex ways which aren't understood.
So before we transition into the advantages of dyslexia, I just want to needle you a little bit to go back to giving us a plausible definition of dyslexia, because it's really been diluted in the last number of years.
Yeah, well, as I've said before, I think the modern way of defining dyslexia is useless, because it is essentially calling anybody who can't read dyslexic. And I think the actually crucial feature of true dyslexia is a discrepancy between oral intelligence and nonverbal intelligence. And if you take a slew of tests for an IQ test, they all come out at about the same level. So let's say if you're dead average, they'll all come out at a standard 100. But in the case of dyslexia, there's going to be a big difference between the one concerned with oral language or visuospatial or non-verbal intelligence and the reading tests of various sorts, and the arithmetic tests. Well, that's another story, isn't it? We haven't talked about. Well, I'm not going to offer to talk about that. I have views on that as well.
Well, you're welcome back if we need to. So let's transition in the last 7 minutes or so into the advantages of being dyslexic.
Well, my starting point is that dyslexia wouldn't be so common, and it is common. Everybody agrees it's somewhere between 7 and 15%, let's say 10% of people are dyslexic. That means that the genes responsible have been preserved. Now, if they only caused a problem with motion sensitivity, they would have been wiped out years ago, because their holders wouldn't have been detected an advancing saber-toothed tiger, and they all die before they had any children. So it's obvious that it must carry an advantage, and it does. In my view, it gives you superior abilities in things other than linear sequencing, and the way of picking it up is to look for superior abilities in what you might call the parvocellular pathways, the static visual pathways, to put it in a more general sense, in holistic kind of thinking, which depend upon you seeing the whole picture rather than just a bit and tracking through it. So holistic tests, such as impossible figures or figure from ground or things like that, are much better at picking up dyslexic's talents. And those talents, incidentally, are generalized to being able to pick out the essentials of a complex situation much more quickly and intuitively, as it were, than what I call normal people, ordinary people. And the dyslexics can do this in all sorts of, you might think, unlikely situations. And one of the things I've been particularly interested in is the number of dyslexics who turned out to be incredibly good at picking out oddities in complex scenes. For instance, we have a thing called GCHQ here, which is a department of the government which is looking for espionage and picking up messages that are in cipher, but between people trying to do naughty things, right, in cyberspace. And one of the things I was intrigued by was to read that they deliberately look for dyslexics in order to employ them, because they have discovered by trial and error that these people are incredibly much better than ordinary people at picking up a pattern of messages that don't add up to nice behavior. Let's put it that way.
Well, and I think more to the point is that they're good pattern detectors.
Yes, that's what I was saying in a very low, roundabout way. Yeah, they're good at pattern detecting because they can see the whole pattern at once, as it were, rather than having to look at individual bits of it. So my favorite tests of this is what are called impossible figures. Impossible figures are like Escher's staircases and things, which are impossible because you go down the staircase and you suddenly find you're at the top again in the picture.
One of the intriguing things for me is when I dial the clock back a few hundred generations, when it was predator versus prey. And I frequently said that a prey animal survives by their coloring and camouflage, lack of movement, the proverbial deer in headlights, and they're fast, short-term sprinters. And if we could talk to prey animals, they'd all get diagnosed with anxiety disorders and paranoia because they think they're being followed. But you're not paranoid if you really are being followed. And if you're a prey animal, you're being followed all the time. And predators survive by seeing fast, right? They've got to detect motion in either straight ahead or the periphery. They've got to be able to predict the future so that when a prey animal's running away, they've got to predict where they're going to move to at the next point in time in space. And we have to be good pattern detectors, and we have to be able to see in 3D. Because if you're going to shoot something or throw something at a prey animal to bring it down, you've got to have good 3D vision. So in the conversation we're having today and about the survivability of this gene pool, well, I could easily see a hunting party going out, and the dyslexics, as it were, would be the pattern detectors, and they would be looking for prey that's hiding in the brush. And those that had good 3D vision, binocular vision, if you will, would be those that are going to shoot something, throw something, otherwise bring that prey animal down. So it would be a symbiotic hunting party to go out and hunt in that manner.
Absolutely. I'd absolutely agree with you. But I would sort of simplify it a bit and say that what's important about the predator is that they're very good at timing and therefore predicting what the prey are going to do. And that gives them they've also got good 3D vision, etc., but it doesn't make them good at finding the prey because they can't see them if they're well camouflaged.
Yeah, so that's that dichotomy of I need both of you on my team.
Yeah.
So if I've got the binocular vision and good magno function, my timing's good, but maybe my pattern detecting abilities aren't that great.
And that's why it seems paradoxical often to people that dyslexics make incredibly good computer programmers. Well, not exactly programmers. They make very good systems analyzers because they can see the whole picture, as it were, of the computer program and see where it's gone wrong just by looking at how bits don't fit into the pattern. So they make very good system analyzers. And nowadays, because computer programs can detect stupid errors, misspellings and so on and so forth, they're not so at their pattern detecting abilities are very much sought after. And the fact that they can't spell doesn't matter.
Well, and I suppose more to the point is that they're good pattern detectors. And so what I see, and we talked about that earlier in the show today, the biggest challenge, if you're a true dyslexic, is to survive compulsory education and not get your ego and your spirit crushed in the process.
Absolutely.
Because if you can survive compulsory education, you can go on and pursue a life that plays to your strengths, not plays to your weaknesses. And when you have the ability to take complex data and see patterns into the future, it's why these folks end up being the CEOs of these really successful companies.
But they depend on their secretaries to spell properly.
Yes. Yes. And you know what? I would take being the CEO and hiring the people that do the sequential processing for me. And I can just sit back and look at these big patterns and make predictions about where I'm going to drive my company and not worry about the fact that maybe I don't like looking at print because it hurts.
Yeah. The bottom line of this is we should be altering our educational system to suit them, not waiting for them to fail, because that means that we're sacrificing a huge amount of talent because the people who would become the successful Charles Schwabs or whatever very often end up in prison because they've been so battered by their educational system. They've just given up and they're pretty good criminals.
Yes, yes, because being dyslexic has nothing to do with your intelligence.
Absolutely.
And that's a point to make too, because if you've got a child struggling to read, it invariably has nothing to do with their intelligence. And I can't drive that point home enough. We need better diagnosis and a better realistic plan about what you need treatment-wise and a developmental hierarchy in which to do it. Just doing more reading instruction is like pouring gas on a fire. It's not going to work if you don't know why it is that your child can't move, look, and listen. And
I couldn't agree more.
And as we've been saying in the 2 other episodes, it's timing, and timing is driven by magnoneurons, and they're in vision and auditory, in motor, in proprioceptive, and we just need to appreciate that timing component and be able to remediate those timing outcomes to the best of our abilities to do so.
Yes, but I think we also ought to allow the educational system to work on their strengths. I mean, one of the problems at the moment, at least in this country, and I think the same is true in the USA, is the children get this perpetual diet of phonology, which doesn't help them at all, because that very much is trying to educate their timing systems, which is hopeless. So what you've got to do is to train them to use their visual static skills to remember the shape of words or the pattern of words or things like that. But nobody will do that nowadays.
Well, and the other thing that's, I think, wonderful about the technologies that we have today is that with technologies that we have available, you can do text to speech and speech to text. And it really facilitates that true dyslexic's ability to communicate through language in a way that lets them route around the profound dyslexia that they might otherwise experience.
Yes, but the problem is then it relieves them of having to find more complete ways around the problem. I mean, you find that successful dyslexics have very often worked out ways of not exactly avoiding reading, but using a different strategy than they've been taught. They've worked out their own way, which is often different for different dyslexics. And that actually has been a useful thing for them. Whereas if you give them too much computer help, as it were, with text to speech, etc., you're avoiding them working out those compensatory strategies. It's slightly dangerous to make it too easy for them.
Well, that's right. I'm not saying that you shouldn't be reading, but we've got to find better strategies for you than generally what's currently available.
I agree.
All right. So as we wrap things up today, my takeaway from today's show was a couple of items. One, we can't reemphasize the importance of omega-3 fatty acids. You just have to do it. That's all there is to it. And then secondly, there's some interesting, I really appreciated the chromosomal discussion today, and I'm going to go read more about these, but that's just the kind of geek that I am to want to know this information. And then the final message is that dyslexia really does have some advantages, and we just need to help you understand what those advantages are so you can ease up on beating up on yourself if in fact you're dyslexic. And we want you to understand that there's a gift to be had in this whole discussion.
Yep, I absolutely agree. Your pattern recognition is fantastic. Don't think that you are worse than other people. You're much better at that.
All right. So with that, Dr. Stein, thank you yet again for coming back and doing another show. Really appreciate it.
My pleasure.
Thank you for listening to the Move, Look, and Listen podcast with Dr. Doug Stephey. All of the resources mentioned in this podcast and links to learn more about our guest can be found in the episode notes from whichever podcast app you might be listening with. You'll also find a link to Dr. Stephey's website, which is stepheyoptometry.com. That's STEPHEY optometry.com. You can also call the office at 626-332-4510. We'd like to take a quick moment to thank our sponsor, Audible. If you love podcasts, you'll love listening to audiobooks with Audible. Many of the books mentioned here in the podcast can also be found at Audible. Dr. Stephey has a free audiobook waiting for you as a gift just for listening to the Move, Look, and Listen podcast. Simply click the link in the show notes to audibletrial.com/inbound. Sign up for a free 30-day membership trial, and you can download any audiobook you like. And if for any reason and at any time you choose to cancel your membership, you get to keep all of your audiobook downloads. It's risk-free and for free for 30 days. Support the Move, Look, and Listen podcast by visiting audibletrial.com/inbound. We really do appreciate you listening. And until next time, for Dr. Stephey of the Move, Look, and Listen podcast, I'm Tim Edwards with the Inbound Podcasting Network.